Before that, I would like to know what samples are you guys going to run to analyze?
Organic drug.
Okay.
Yeah.
But in which object? Like, what's the target? Like, for example, okay, from my background, we are dealing with plants. We're dealing with leafy crops.
Yeah.
And we're trying to
You
find.
mean the sample matrix?
Sorry?
You mean the sample matrix?
Yeah, the sample matrix, right? Water. Okay, sure. Yeah, because my background is dealing with like all these leafy crops, and we are trying to identify the metabolites in general. But for you guys are trying to target all these drug-related compounds, right? So cool. Okay, cool. I mean, I think the protocol, everything will be pretty much similar, except the extraction might be a bit different, which I assume that you guys have your own protocol for that. Yeah. So that you guys have to figure it out. I mean, I can send mine to yours, but I think it will be totally different thing lah. But that will be just for your reference. Okay. And also another part is that I think you guys might need to come up with your own, what do you call this? And basically the experimental parameter setting. So for example, because like when it comes to LC part, we go through this so-called gradient illusion.
Yeah.
Yeah. So I assume you guys have your own protocol as well. Because I mean we are dealing with metabolites, so it might be a bit different setup.
Okay.
Okay.
Yeah.
Yeah. So this you guys have to figure it out, and what I can do the most is just to guide you through how to basically flush the system, and also how to adjust it to the so-called the parameter settings that we wanted or we desired to make sure the experiment can run smoothly.
Yeah.
And then calibration, all this stuff. And so yeah, this is a parameter setting. Let me just quickly go through first. And then we have to do all this calibration just to make sure that everything is fine before we can really run through or go through our own batch of samples. And then basically, yeah, calibration, and then you just load your samples. But it's a bit complicated here, so I'll have to guide through you guys.
Okay.
So this is one example. This is from another student, actually from our group. She's dealing with a bacterial sample. Like, I mean, it's a human sample actually, skin sample, skin cells. And she's trying to target like all this bacterial stuff. So she had to come with her own protocol. Yeah, and all these settings. This is one example, so I don't think we will refer to this. It might be a bit different. You guys can take a look.
Do I need to change the column? Or...
Okay, so we have our own column inside.
Yeah.
Usually, I mean, because you guys are targeting different things, right? So it's better to have your own column. And yeah, of course, you need to change your own column prior to run your own samples.
Okay.
Yeah. Because I mean, we so far we don't really share lah. I mean, we can, but it's just we're just trying to avoid contamination, all this stuff. Yeah. So it's better to have your own column and change it every time you run your samples.
Okay.
Yeah. Okay, so let me go start with this. Okay. This computer, I mean, the password is just here. TOF5600 at NERI. My gloves are clean, so no worries. So okay, let me maybe just shut this down first. Okay, we just start from the beginning because I was actually trying to flash the column just now.
Okay.
Okay, so basically once you log in, you come to this home screen. So what you do, you just go to this Internet Explorer, and then you go to this Xeon LC control. So the first step is that we're just trying to flush the LC system. Okay. Once you get in here, yeah, especially. So you just refer to this. The user ID is admin, password is also admin. Yeah. Admin. Okay, so you will come to this. Okay, so first thing, usually we'll change the solvent to the mobile phase that we intended for use. So in our case, we use pure SEN and also pure water.
Okay.
Yeah. So if you take a look at here, this is where you change your solvent, right? So usually A line and B line. A for like, I mean, it's easier to remember. It's just aqueous. So usually it's for water, and then B is for all the other solvents, but in our case it's RCN. Yeah. Yeah. So now I already changed it up to pure water and pure SCN.
Okay.
Okay, and then so here written that we need to purge it for, okay, so there are two steps here basically. We change it to pure water and pure SCN, and then we purge it for 10 minutes. Okay, for both lines A and B. And then the second step after the purging for the first step, you change it to, it's the same thing, except we added 0.1% FA, formic acid. Yeah. So now we just go through the first step. And this will take a long time. So everything is just changed to 10 minutes. Okay, and then you just start auto purge.
Where do you open that?
It's just here, purge.
Oh, okay.
Yeah. Okay. So yeah, this one will take quite some time. I'll just leave it to its own to run. Yeah.
Up to 10 minutes.
40 minutes.
40
Yeah, because 4 times 10, right? So it will take up to 40 minutes.
Okay.
Yeah. So here you can just, you know, take a stop and break. I mean, usually here, until this part, I will just go to do some other stuff. So I'm doing sample extraction next door. Yeah. Okay. So now we're just going through the second step of purging. So basically you just change the pure water with another pure water, except we added with 0.1% FA, formic acid. Yes, it's a C18.
Okay.
Yep. I can show you guys if you. So by right, this one, when we do purging, we need to take it out as well. But even if you leave it, it's fine. But I mean, just for your reference, I'll just take it out first. Yeah.
Okay. Yeah, this is just the
Think.
normal HPLC.
Okay. Yeah. So just put it aside. Just a minute. So usually when we do purging, you can remove the column, up to you. It doesn't really make a difference, but I'm just showing you guys if we do it without the column. So there's this nuts, you just connect it instead of using the column.
Yeah.
Because sometimes they worry that the flushing might cause damage to the column. But I mean, so far I've done that. I don't see any damage so far, so that's why I never really bothered to change it. But this is like the proper practice that you guys should follow actually. Yeah, they just close it. Okay, then once this one has been done, so this one to change as well. It's the same thing, pure SCN to SCN with 0.1% formic acid. This one we use the aluminium foil is because we worry that they just to avoid the formic acid degrade. Okay, so once we change it, we'll just do the second step of purging, which we basically just change everything to 5 minutes. Yeah, so this one will be faster, will be just 20 minutes. The total purging time will take up at least 1 hour. Yeah. So it's always highly recommend to do this before you want to do anything else. Like if you want to proceed with sample extraction or sample weighing, all this stuff in the morning. Yeah. Usually this will be the first step when I come here. Okay. Switch it off. Okay, so basically now we're done with flushing the LC system, and then the next step we need to do is to flush the column. Yeah. Actually, I've already flushed the column this morning because I was running some samples over the weekend.
Okay.
Yeah, so, but anyway, we'll go through again. This will be quite fast. So the next thing, before you flush the column, of course you need to install a column, right? And if you ever look at this column, you'll notice that there's actually a label here.
Yeah.
So you see the floor, the direction of the floor.
Yeah.
So basically you need to try to follow this direction accordingly. Okay. Okay, so usually the direction of the flow will be, so here will be the auto sample. This is where you load your samples, and then the needle will actually inject through your vials here, and then you extract the samples from here.
Yeah.
So the direction will be starting from here through this red line, this small red line here. Yeah, I'm not sure we can see. There's a red line here. So this is from connecting the auto sampler. So, and then this is where you install your column, right? So basically the direction will be here to here and then goes up, then through here. So eventually this will be connecting to this MS machine. Okay? So make sure you know the direction of the flow so that you can install the column properly. Okay, the next thing we just install this column. So the direction will be going up. And this one, try to make sure it's firmly connected so that there won't be any leak. But eventually, if there's any leak, the system will give you some alert as well, so don't worry about it. But just to make sure it is tight. Okay? So now it's pretty much done for installing the column. Alright, so the next thing is click the reservoir. Okay, this one is not really important. The reservoir will be reflecting to the volume whatever you have in these glass bottles. Yeah. This one I have to top out later, so I won't fill in anything first. Right. The storage column storage condition, ours is SCN 75%. So this one is already done, and what you need to do, usually we start from 0.1, the lowest flow rate. Okay. Okay, so if let's say you want to, if you're not sure about the condition of the column, maybe you want to just go through it, right? You want to flush it, so you might as well start with 5%. This is what they recommend here. Take your initial mobile phase, flush the column from column storage to initial mobile phase in the intervals of 20% and 25%. So if you want, 5% means 5% SCN and then 95% of water. So this is the best way to clean it, starting from the highest water percentage.
Okay.
Yeah, so basically you start with 5% at 0.1 flow rate, and then you click pump. So eventually you will notice that this bar will be increasing. Yeah, it started from 0 to somewhere, I think will stop around like 20 something like. So this is a good benchmark that you guys should take note as well. Take note as well, so that you will know what's the condition next time when you come and when you want to run your samples. At least you get a hint of what's the benchmark that the pressure will stop at. Because if the pressure here is anything higher than whatever you expected, then it means that your column will be probably contaminated in this case. Yeah. So this is a good benchmark that you guys should know. Just wait for a while. So usually once we press the pump, it means start flushing, right? And then this pressure bar will be going up and down, it will fluctuate. And then how you can see is from here. So usually here I will wait like at least 1 or 2 minutes just to make sure that it won't fluctuate. If it shows something like this, like a straight line, it means stable, which means there's no contaminant inside. Yeah. So this one I will just wait for a while, maybe like 2 minutes first. In intervals of 20 to 25%, right? Because we started with 5%, so later on I will just add another 20%, which means 25. Then so on and so forth, 25, 50 and 75. Yeah. As long as every time I change the percentage and then the pressure bar is consistent, like very stable, then there will be no problem with the column. Yeah. If you're noticing something fluctuates very frequently, then it means something wrong with your column, or maybe with the LC system. Yeah. So that's one way how we observe if everything is functioning well before we want to run our samples. But if not mistaken, I think it will go up to like 22, 23. Yeah.
You help me run that. Yeah, I also want to run. Okay. I want to try it. I want to find.
Okay, so now it's about 22. It seems like quite stable lah, starting from here onwards, right? So now I just change it to 25. Here I won't expect much changes lah. It will be still somewhere around 22, 23. But I will just keep it for like 1 minute at least.
After you change to 25, you click come again.
No need. So once you change the number here, you just click somewhere else.
Oh,
If you click pump again, it will turn off. Yeah.
Okay. So I think I go 22 bar and then change to 25 bar.
25%, yeah. So now it'll be water will be 75, and then the BSCN will be 25%. Yeah. And then once you change it to 50%, which means half-half, right?
Yeah.
So usually because water will give higher pressure. So eventually, sorry, no wait. Yeah, usually water give higher pressure, which is what we're observing now. So once you change it to 50-50, SCN started to give, I mean, like, occupying at least half, right? Which means there'll be less water. Which means eventually the water pressure, I mean, it will be less pressure given from the water. Then eventually you'll notice the pressure bar will actually drop a bit. And then once you change to 75 or maybe higher than 75, it will drop dramatically, like somewhere around 10 to 13 bar only. Yeah. It's only the water giving the pressure now. Mainly, I would say, majorly. Yeah, so you notice like after I change to 25%, it's just quite stable actually. So in that case, I'll proceed with 50%. If not mistaken, 50% I think it will drop all the way until like 20 bar. But this one will take some time. Maybe 3 minutes ago. Control the whole LC system. And if you want to control anything on the MS machine, will be this software, Analyst TF. Okay, so when you come to this interface, because I mean so far I've been using my own project lah, Alvin LCMS. So whenever I need to run a new batch, I'll just click this new sub project, and then it will automatically create one sub project based on today's date. Yeah, so today is 13 January, right? So I just click OK, and then you will notice it change to 13. Yeah. So okay, this one I can do in parallel together. So while I'm cleaning that whole LC system, I can do a bit of calibration here as well. So maybe you can jump to this page. Okay, just here. So open the Analyst here, which is this software, and then you just go to this hardware configuration, which is where we are now, and then you click the triple TOF with CES only. Yeah, so you just activate this profile. So it's just like the two-step purging. This one will be 2 steps as well, as in 2 steps calibration. So the first thing we calibrate will be this, the tool set will be here, triple TOF. But it's just a method, okay, when it comes to this tune and calibrate. So there are two scan types that we need to calibrate, the TOF MS and also the product iron.
Okay.
Yeah. And then the first thing we will do is the TOF MS. So tune and calibrate and then manual tuning, right? Then, yeah, you just select TOF MS as your scan type. Okay. So because I'll be running mainly negative, so I just choose a priority as negative. Yeah. I'm not sure if you guys going to run positive. It's more related to lipid related stuff. Yeah. Okay. So once I change to negative, and then you just follow the parameter here. So there's this source gas parameter, which is under this tab. Yeah. It shows that 50, 50, 25, right? Okay. Then I just change accordingly. 25, and then the temperature. So this one, okay, because I know that my flow rate will be around 0.5, yeah, so I just follow 500. And then for the iron spray voltage floating, because mine is negative, so negative 4000. Yeah. And then the next thing that you want to adjust will be your compound parameters, which is under this tab. Yeah. Negative 100, okay, for declustering potential, and then collection in energy will be negative 10. So this one remains the same. Yeah. Then the scan type is 0.25s. So here don't change means because this is by default. It's about 0.25, so just don't change it. Then the TOF masses will be 100 to 2000. Okay. Once you're done with this parameter setting, you go to calibrate from here. Okay, and then this one you just change accordingly as well, 300 and 1000. And this one, the reference table, because I'm doing the negative one, right? So apparently it's a PCI negative calibration solution. Yeah. And the calibrate, of course, you can choose. Ours is using the APCI for now, so I'll just choose the APCI instead of all the others. Yeah. 300. And then here you notice that it asks you to click on CDS purge. So you just need to purge from here. Before I click this purging, I'll have to check the calibrate solution, which is here. So if you get to notice that it's somewhere around, it's 2.5 ml, right? I think I may top up for this.
When you get it?
Okay, so it's in the fridge. Positive, negative. So this is negative APCI carbon solution. Sorry? Yeah, it's APCI negative. So if you want to run positive, it will be here. This one will be the positive one.
You also have.
Yeah, yeah, it's in the fridge. Alright, so now after we top up the carbon solution, we just click CDS purge. So this purging for CDS will take up to I think 5 minutes. Yeah. So you notice that the blue light is actually blinking. Yeah. So that's when it's stating that it's actually purging. Yeah, the CDS. Okay, while purging that, we'll come back to this flushing the LC. The column. So now you notice, right? It's back to 20. It drops a little bit. Yeah, expected lah. Okay. And then I just change it to 75. And here I think it will drop until like 13 bar. Yeah. So throughout these different intervals, you have to be familiarized with the pressure bar here. Yeah. to make sure that everything works well. I mean, if there's like about one, 2 bar differences, I think it's still okay, it's acceptable. But if anything more than 5 bar, then you might need to be careful. It's either the LC or the column again. Yeah. If you see something around like 13 or 14 bar, which means everything is okay, right? So this is where you can, I mean, allows you to go proceed with the next step, which is to connect with the MS machine, which means everything LC here is fine. Yeah. So yeah, I think just get it to 13 bar. It's all good. So here I'll just stop pumping. Yeah. I mean, if you never stop, then the pig tube will keep spraying. Yeah. So this is a pig tube. So this is how you just connect with the MS machine. Yeah, is it? Okay, just screw it properly. So basically now these two is connected to each other. Okay. Okay, here again, after you connected to MS machine, you want to make sure that everything, the pressure is still remains the same. So again, you just click pump just to see whether it hits somewhere around 13 to 14 bar. Yeah. No. So it's like something around like 13, 14 bar. Yeah. Yeah, of course you turn, because there'll be no pressure. Yeah, there'll be no water going through all this. Yeah. So it will drop to 0, and then once you click again, then it will go back up. Yeah. So okay, because the ideal, I mean, in my experiment, my flow rate will be 0.5 flow rate, right? So eventually I need to change it. I mean, adjust it to 0.5. So here they suggested initial flow rate will be 0.1 ml per minute first. But yeah, here you can see once connected, increase the flow rate to initial mobile phase flow rate slowly in intervals of 0.1 to 0.15. So in my case, I'll just do 0.1, 0.2, 0.3, 0.4, 0.5. Yeah, to my desired flow rate. I start at 0.1 just to check everything was okay. Because the pressure is supposed to be the same lah, before connecting and after connected to the MS machine. Yeah, 75% will remain the same. Yeah. So now what I need to do is just change to 0.2. Then you see changes lah. Because apparently if the flow rate increase, then your pressure increases as well, right? Yeah. So it's kind of expected here. 28. But this one I'll just let it go through like the same thing, 1 minute to 2 minutes. Just to make sure it's stable. Yeah. Using your own column, just try to make sure you don't damage, I mean, try to protect the column as much as possible lah. Because I mean, in a way, it can be quite fragile as well. If, for example, if you start from 0.1 flow rate and then you suddenly change to 1 ml, you eventually will damage the column. Yeah, so it's something to be careful, to be aware of. Okay, so now I just change it to 0.3. Again, it will increase.
Waiting for 1 minute, 2 minutes.
Yeah, 1 to 2 minutes will do. Yeah, you can see from here lah. You can check from here this graph, so you can see where it's quite stable. As long as the straight line is fine. So 0.3 is about 43 bar. And then now we change it to 0.4. We will increase up to, I think, 56. Yeah, 56, 57. Somewhere out there. 5. So this will be the flow rate that we wanted to run my samples. So this pressure is actually within the acceptable range. The ideal range is about like 70 to 75. So 72 is totally acceptable in my case. Okay. Okay. So once this one is considered done for the LC part. The condition is there for LC, and now we go back to MS. Right. So because we have already done with the CDS purging, right?
Yeah.
Which is here. Okay, yeah, so as I mentioned just now, purging took 5 minutes, and then the blue indicator stopped flashing, the purging is completed. So on NRSTF, ion source temperature, so you need to check whether the condition is there or not. It's here. Ion source temperature reached, yeah, okay, so it should be seen. And then the next step you need to do is just click start. Yeah. So you get to see all this window pops out. Yeah. So apparently it's calibrating lah, but we need to inject the calibrant here. Yeah. So click start, and then the TIC and MS window should appear at the bottom of the screen. Okay, which is what we're seeing here. So this okay, and then you just click CDS inject. So this is where you inject the calibrant into it. So once you click CDS inject, right, you get to see this peak. You just spike up. Yeah. So without spiking out, it was just somewhere around like 1.2 E6. And once you injected, you will spike.
This inject directly into the QTOF.
Yeah.
So it doesn't go through the.
Not yet. That's the second step. Yeah. So usually for this part, the first step calibration, the same thing, you just have to wait for like maybe at least 1 minute lah, as long as it's stable. So I won't take this range because it's not stable, right? You see there's this spike up, then this one is like going down a little bit. Then I'll probably start taking the range, will be starting from like 0.7 here. Or maybe if you want a bit further up, will be 1 to 2. TIC signal is low, which means here, if the value here is like lower than 5,000, then yeah, you need to click stop, and then you need to refill the calibrant. Sometimes it's just a CDS. The calibrant never just pump into the system. That's why it's not detected. Yeah. Okay, so seems like I can probably take the range from 1 to 2 here. It looks quite stable, right, within this range. Yeah. So what I want to do is highlight the TIC, which is stable. Double click on the selected region. So after you highlighted, double click it. Okay, you come up with this another window, and then you right click on the TOF MS spectrum, which is here, and then recalibrate TOF. Yeah. Okay, see this? Recalibrate. Okay. So just click on it. Right here, the reference table, apparently you go with the same one, right? APCI negative. Yeah. Okay, you get to, once you click the APCI, negative calibrant reference table, you get to see all this error stuff. So what to do next? Calculate the new calibrations. Yeah. So the average error is as this high, but after you calculate it, you drop until 0.57. Yeah. So the ideal one, they said average error is less than 2 ppm. So this one is acceptable. Okay. Then the next step, okay, if it's not, yeah, you just click review again. It's the same thing. If it doesn't hit the well, I mean, apparently if it's higher than 2 ppm, yeah, that's one way to check lah. Okay, it's either that or maybe this one is not showing like this curve. It will be very ugly while you keep fluctuates. Yeah. Right. So next step, calibrate the spectrum. So everything will be calibrated. The first part will be calibrated based on this range, and then just for backup, you just save the entire file as a proof that you have already calibrated. Yeah. And then everything pop up, you just click OK. Then only TOF MS scan negative, already high resolution will calibrated. Just click OK. Then close it. Then just click OK. Then OK. Right. So up to this point, What's the next step? Okay, so because we're done with this part, right? Then the next thing we need to calibrate is the QTOF MS. So now this one you can just stop. Yeah. Then delete and then you just go back to this MS method. So because the first one we will calibrate is this TOF MS, right? Then now we need to do for the product ion scan type. Okay, so it comes to this part for the ion. Again, you just need to change the parameters accordingly. Yeah. So this one, source gas parameters will be 50, 50, 25, 500. It's more or less the same now, okay? Yeah. And then the MS method parameters, okay, this is the one that you need to change. So scan type, apparently I already changed for the ion. Then product of, because I'm following negative polarity, right? Yeah. So you just follow this 403.1122. Okay. Accumulation time 1.s. This one no need to change, it's more or less the same. Then 50 to 2000. Okay. And then the next thing you need to change is compound parameters. It's under this tab. So you request because it's negative, so negative 80. The next one will be negative 30 for collection energy. The energy spread will be 10. And then 67 and 25, so it remains the same. Okay? Right, again, the same thing, you calibrate again. So, yeah. Yeah, again, if you somehow notice that the volume is low, you just top up from there. Otherwise, you can just proceed to start. So this one by default, the TIC here will be low, the reading will be low as expected. So what I need to do now is to inject. Okay, here's I'm not sure if it's a bug because sometimes after you click CDS inject, right, you won't see a peak here. You don't see anything spike up. So which means you need to refill it in this case. Yeah, because it's not spiking out, right?
So stop and inject everything.
So even if you click stop, I think it's maybe it's a software bug. It just doesn't stop. So I just straight away stop from here.
Oh.
Okay. And then you see this button, you just never go back. Yeah. So one way to fix it is just you click CDS purge. And then stop it directly. It's a bug. Apparently it's a software bug, yeah. So now what we need to do is to CDS refill. Because the value here doesn't hit the acceptable range. So this one will be quite fast, 1 to 2 minutes only. And if you ever notice this icon here, this one actually reflects the condition of this MS machine. So if it's green light, it means everything works well. Yeah. So every time when I encounter some problems, this one will become red, and then you can check from here.
Okay.
Yeah. All the voltage, as long as you see the reading is like fluctuating, then it means normal. If it's not fluctuating, then there's a problem. Yeah. Yeah, as long as green light is fine. To see this option, right, for this CDS inject. So again, you do the same thing, you start all over again. For this second step calibration. And then once you click inject, this time it should spike up. Why is it not? Okay, yeah, there you go. It's a bit delay. So same thing, this one must be more than 5,000 as well.
Okay.
Yeah.
So you drop from 1 to 2?
Yeah. You can drag from, in this case, I think 0.5 to 1.5 also can. It seems quite stable within this range as well. But it's just my practice that I usually wait until like 1 minute, then I only start dragging. Okay, so between 1 to 2 it seems normal, so I'll just select this range as my ideal range to calibrate. So I just double click, doing the same thing, recalibrate TOF, and then choose a correct reference table, calculate new calibration. So it drops to 0.36, which is okay, lower than 2 ppm. Same thing, calibrate spectrum, then you save it as evidence that you have done your calibration. Okay, so basically we are done with the 2 steps calibration now. So which means LC is fine, MS machine is well calibrated, so everything is fine to proceed with your experiment. Yeah. And then now the next step will be just loading your samples. So I can just stop this first. So you see, once I stop, it will just drop. Yeah. Stop. Okay, I'll just close everything. So I think this is another bug, like a software bug. So if you ever notice, if I click this delete pane, it actually works. Okay. Yeah, sometimes it's just lagging there. Yeah, it just doesn't work. It will crash. Okay, so anyway, okay, so now we just need to start log out from the LC web control. So because this one is only connecting to the MS machine for now, right? And now we want to connect both LCMS and also, LC and MS on this interface. So which means we need to connect to this. But in order to activate this profile, you need to log out from this. Because just now we're using this software to control the LC to flush everything, right? So what you need to do is to log out. Before that, just to make sure all this pressure is within the range. Yeah. It's all the same, right? Okay, so just log out from here. Because okay, I can show you if okay, so I deactivate first. Okay, so if now I want to activate the profile LCMS together, you will see this alarm prompt to us. It shouldn't be activated. It should not be. Yeah, see? Because failed to initialize the LC controller, which means something is taking over the control, which is this app. So you have to allow from here. Okay, once you log out, and then you just retry again, it should be working this time. Yep, there you go. Okay, so this is how you activate this LCMS machine. Yeah. So it's the same thing, you just log out from the QTOF with CDS and then you activate this LCMS. Yeah. Okay, so when you come to this part, the creating project, I already did that in the beginning. Yeah, so this one you can just skip. Okay, this is the part you guys need to figure it out yourself. Acquisition method. Yeah. So because I have already a preset method, so I will basically just copy and paste everything, which is very easy. But for you guys need to figure out analyst data, projects, and then LCMS. So I did my run previously on 9th, I think it's last Friday. And then I'll just go to this acquisition methods. So we name it as a 30 minutes MS. Just copy and then pass it to today's acquisition methods. There you go. So that's how I just straight away open. Okay. But for you guys, you need to start from beginning. You need to come to this acquire and then build acquisition method. Yeah, you just have to key in all your parameters here. Yeah, so everything here lah. LCMS, you have to adjust yourself. But in my case, I don't need to do all this because I already have a preset program which I can just open from this file. Yeah, 30-minute MS. Once I click OK, just from here. Yeah, under file, open. And you just click, just select the file type, them, and then 30 minutes. So once I open, you get to see all this is already set up. Yeah, it was set up by my senior a long time ago. So I just follow it. Yeah, this is the one, especially the gradient curve. Then you need to set. Yeah. Okay. So all these preset, and as long as I open it, I can straight away jump to loading my samples. So this one, we'll leave it to you on. Injection, production ion. Okay, so I'll just jump here. Yeah, so after 30 minutes, MS. So I'll just create a batch file. Alright, so I'll just go to this build acquisition batch. Okay, and then click add set as samples. So I'll just name it as a set 1 lah. And then you add set, add samples. So because I've already extracted 60 samples, and then usually I will include my own blank samples and QC samples. Yeah, so usually I'll make up like maybe 70. Yeah. Okay. This one I will just create a 10 first, like a blank one to, and then I'll delete again. So this one, because okay, it's a naming issue lah. If I start from here, right, and then everything, the order will be different when it comes to the downstream analysis. Like it will jump lah. Like I think it will start from, I don't know, 111 and then 112, and then apparently it will jump. It will skip the 12, and then we'll go to. I mean, it's just a matter of the order is being messed up in downstream analysis. So usually I just throw out the first 10. This is my own practice. Up to you guys whether you guys want to follow or not. Okay. So you just delete the first 10, and then you just second time you only key in the correct number. So here I just put, I think 75 today. Yeah. Okay, so you get to create all these template 75 samples, and then you have to change the method for each of the samples. So everything will be the same for my samples, 30-minute MS. So once you click, yeah, everything will change accordingly. Yeah, you automatically change everything for you. Okay. Okay. Then the next step. I mean, all this I usually don't change. Oh,
it's already set.
Yeah, it's by default. I'll just go by default until the allocation part. So here I get to choose. Okay, there's only one option here, which is 105 vials for 1.5 ml. Yeah. I mean, we don't have any other racks, so there's only one rack which provide you this option. So once you click in, okay, here you have to decide the order or the sequence that you want your samples to be extracted or injected. So usually my pattern will be going like vertical lah. I'll start from here, 1, 2, 3, 4, 5, 6, 7, all the way. I'm not sure if there's a faster way to key in all this number, but I mean, this is the only way I found lah. Just to click one by one. So all the way until 75. Okay, 75, right? So I'm done with the location part. Then calibrate. Okay, previously I used to do auto calibration, but I thought like it's just a waste of time and also waste of calibrant solution, so I just turn it off. I don't do that anymore. Because I mean, eventually I don't really check back all this calibration stuff. So except for the one before we run every batch, before run, yeah. So this one is not necessary lah. I'm not doing any quantitative, so if you guys dealing with that, then you might need to do some adjustment for here. I don't know how you guys do it lah. I never done this before.
Oh, I never done quantitative.
Yeah, so you guys have to figure out if you want to use it.
Okay.
Yeah. Okay, so once I confirm everything is set up properly, 75 samples and then 30-minute MS, then yeah, I'll just click submit. This one batch owner name is just a name, it doesn't matter. Oh, sorry, submitted. Okay, so how you can check, you just go here, view queue, and then it should show you, okay, yeah. So you get to see this, let's see whether it's 75. Yeah, sample 75. So this is done lah. This is symbol of done. This is the previous done. And this is for the calibration just now we done. And then these are the samples in queue. Okay, so I have 75, which everything is already on the queuing on the system now. So what I need to do next, so view queue. Next step, you just equilibrate the system for about 2 to 5 minutes. Then make sure T is not clicked. So because now T is clicked, so this one is to reserve instrument for tuning, but we are done with this, right? So we just unclick it and then equilibrate. So 2 to 5 minutes. I usually go with the 5 and then click OK. So you get to see this. Just now was in, like, I think it's Q out something, and then it changed to warming up. So it will warm up this oven because the condition here is supposed to be 40 degrees. Yeah. So you just wait for 5 minutes.
So if you don't never do the quantification, you like how you will not know your sample.
Yeah, because I'm just doing screening.
Oh, okay.
I'm just doing metabolic screening, but I'm not doing any like targeted metabolomics so far.
Okay.
Yeah.
What does your result look like?
Oh yeah, I will show you guys as well. Yeah, of course. So while this is running,
Because I want to know if I can get away without doing the quantification.
Okay, fair enough.
I just do it myself using.
You can in a way, but I'm not sure how to do it lah. Okay, so let's say I go back to the one I run on. I did it on Friday. Okay, so there's one way to quickly, because when I first do this, I have no idea how to check all this data.
Yeah.
But sooner or later, I figured out one way to check it to see whether everything is okay. Because there was few times this MS machine went down, but I still keep running overnight until everything is done. Then I thought as long as machine is done, then everything should be okay, right? But it's not that. It's not really that. Matters. Because sometimes, even though the machine done running, but there might be some problem within the system itself, right? So eventually your data might not be accurate. So one way to check it is that you can check from the size, the file size.
Oh.
So because remember I told you that I have blank samples, QC samples, and also my own samples, right? And yeah, so you get to see it's very obvious one. Blank samples is as high as 3,000 something.
Okay.
Yeah. So all this, I mean, when I check back, I know all this is my selected blank samples. So if any other file that is like 3,000 something like this, but the other is like 2,000, okay, this is considered normal.
Okay.
This is considered as a blank sample as we expected. So if any samples that occur with 3,000 something, then I know it's either maybe not extracted properly, or okay, unlikely to be the machine because all the others seems okay, right? So yeah, that's one way to check it.
Okay.
Yeah, but if everything is 3,000 something, machine problem. It's very obvious one, yeah. Okay, so I will just show you one example. Maybe it's just start with the blank samples. Because my blank is actually 70% methanol. So you can see the background is as bad as this. Yeah, it's only like one peak only, two peak, yeah. Yeah, so this is the blank. But if you look at the proper exact sample, anything like that, you should see a lot of peak like this.
Oh,
yeah.
So it still shows you the peak height.
Yeah.
So you can quantify for peak height.
You can actually.
If I have a standard.
If you have a standard, yeah, you have to compare. Yeah.
Okay.
But I have no idea how to do that because I've never done it before. I just know how to do it. I know the theory, but I've never done it before.
Okay, I think I can do that.
Okay, cool, yeah.
Because I did LC before.
Yeah, okay, fair enough. Yeah, okay. So that's how I can check the data log after everything lah. Yeah.
Okay.
Because my previous practice was to collect all data at once and then I straight away run the MS DAO. And then only until MS DAO stage, I noticed there's some problems, which is a bit too late. Yeah, so it's better to check after every run from here. Okay, so this was everything. Let's go back to this. Okay, it's still warming up. While it's warming up, I can load my samples into the rack. So this is the rack, 105 vials, 105. So what I have to do is just load it according to the sequence that I keyed in just now. Yeah. So these are my samples, and then I have my blanks and QC here as well. This part by right should wear gloves, but it's okay lah. I mean, I'm going to wash my hands later, so, and it's not very something like dangerous, so it's fine. It's only plant samples. No, I make my own QC samples. So because remember I told you that we are working on all these leafy crops, right?
Yeah.
And for example, we do dealing with pak choy. So even pak choy, we have like different subspecies. So what I do, how I create the QC samples, I take from all these different subspecies, I take like representative. I just pick one or two from them, and I pull them together and mix the powder, and then I split it into like maybe 5 or 4 vials, and that's my QC samples. Yeah, so every time I run, I will take some of the QC sample and then I will extract it in every batch. Yeah, and then that's my QC sample for every run. Yeah. So I make my own QC samples basically.
Your samples originally is solid form, right?
Yeah, the powder.
Then you extract.
Yeah, then I extract in every batch. Yeah.
But mine is already liquid.
Ah, okay, fair enough. So this one, I'll just randomize it. So for my case, I usually will, my practice, I will just load like maybe every 20 or 30 samples, I put one blank and then one QC. But it's up to you guys. You can choose your own pattern. This is my own pattern. Yeah. Okay, and this one, be careful. Always make sure you cover properly, because there was one incident that a student never closed properly, something like this. Then when you put in the auto sampler, the needle actually hit. Yeah, it's just dented lah. It never break, but dented. But once it's dented, you can never use it anymore. Yeah. So what you need to do is just, there's this gap here. Just make sure you slot in properly, and then once you slot in the front, then they push it down. Yeah, you should hear a click sound.
So when this thing comes out, then
no. So this is like the what do you call it, like a switch.
If it's not hit properly, how do you?
So I'll cancel out one sample because I don't have enough QC blank.
Okay.
Yeah, so 74 only. Okay, and then so because I only have 74, I will just cancel one from here. Delete samples. Yep, so 1 at 4. So now you get to see this become ready, right? Okay, so means everything is okay. Then you can perhaps just start samples. And then we go in pre-run. So usually I'll make sure I pay attention to the sound. Like if there's any movement of the needles, then I will only leave the lab. Because there was one time I think I just never wait until everything started because it was still like within this pre-run range. Then I just left the lab, and then when I came back on Monday, everything is not done. It's still stuck on the first stage. Yeah, it means something wrong with the needle or something. Yeah.
You wait for it to change.
Yeah. I'll wait for it until it started like running. I mean, the experiment is starting accordingly, then I'll only leave the lab. Yeah. You can see here will show you the number later. If it's not, then something wrong with the machine. Yours is working. Actually, you can see from here as well. Yeah.
Oh, okay. Okay. Okay.
Yeah. So yeah, that's pretty much the whole LCMS operation.
Okay. Okay. Thank you. Okay.
No problem.
So it's running already.
Yeah, so now you can see, right, it become acquiring.
Yeah.
So every sample is about 30 minutes, right? Yeah.
Okay.
There's a time lapse. Yeah.
When it's finished, does it switch itself off or you have to switch it off?
Well, here will become standby mode, and basically it will stop running, and then it will become standby mode. Yeah.
Okay.
And then what you need to do is okay. So that's the next thing that you might need to be careful. Okay, so everything here is like after you're done with your experiment. I mean, the machine is done with the run. Then to stand by the LCMS after analysis. So the first thing, yeah, the very first thing you need to do is to disconnect this pig tubing, this thing. So because every time after you run every batch, the first thing you need to do is probably clean your machine, right? But before you start cleaning your machine, you have to make sure this one is disconnected. Otherwise, all the dirty things, all the contaminants will go in here. Then once it go in, that's it. Yeah. Yeah, usually I just insert it into here, this hole here. Yeah, so this is the waste bottle. Yeah. So always remember, this is the first thing you should done. Otherwise, once the machine, MS machine got problem, then it's another headache. Yeah. And then yeah, you just deactivate the LC. So you just same thing, because just now we log out from the LC, right?
Yeah.
And then we connect LCMS both together.
Yeah.
But now you do it the reverse way. You disconnect LCMS, you go back to the LC software, and then you flush and purge from there. Yeah. As simple as that.
Okay.
Yeah.
Oh, yeah. Okay.
Yeah. Then I mean, I'm not sure because Shula mentioned that she barely really flushed a lot of the, I think it's a column. She barely flushed a lot, but for me I flush a lot like I will start with 5% of water. No, sorry, the 5% BSCN and 95% water. So I start from 0.1 to all the way to 1. So 0.1, 0.2, 0.3, so on and so forth, all the way until 1 flow rate. Yeah, just to make sure, because the bigger flow rate, then I will assume that it should clean it better, right? Yeah. And then once I hit 1, I will just leave it for like maybe 1 hour, just to let it flush it itself. Yeah, then only I switch it back to 75%. That's the column storage condition. Yeah. So it depends on your practice. If you worry about the column get contaminated or all this, yeah, it's a good practice. Okay. And then after you're done with flushing the columns, you just take it out, then you flush the system. So always remember, flush the column first, then you only flush the system. Okay? Then after you flush the system, just leave it. Yeah, then there will be that all. That's all. Yeah. Purge the LC system for 10 minutes. Yeah. You can either leave it in the pure water and pure SCN, or you can change it to 50% ethanol.
Do we have this like?
Yes. There. Yeah. But this one I only do it once in a while. Yeah. Usually I'll just leave it in the pure water and pure SCN. Yeah. So any question? No question. I mean, okay, it might be a bit complicated. Yeah. I mean, if you guys have any question, of course, welcome to ask me anytime. I'll try my best. Sorry?
You always be here.
Usually I'll be here either on Monday or Tuesday and Friday. So usually Wednesday and Thursday I'm barely using this. No, okay, not to say barely using, because if let's say I do my samples on Monday, it will take up maybe like one day plus maybe sometimes, which means it will last until like Wednesday morning. So if I don't come here on Wednesday morning to flush the system, I will just come on Friday. Yeah. So it depends. Like for example, next week, because Sheila told me that she's coming to use on Wednesday. In that case, I will have to come on Wednesday morning to flush the system so that she can use it. If there's no one else going to use it, then I'll just keep it until Friday. Yeah. So that's the current practice. Yeah. So if you guys need to use, just let me know, beforehand. Yeah. I mean, I'll let you guys prioritize your experiment. Because ours is like ongoing for like a long time one. It's gonna be forever and ever. Yeah. Yeah, can. Sure. Yeah. Anything, just let me know. Yeah. Okay, thank you. No worries.